Thank you. Thank you all. Good afternoon. I know that I'm standing in between you and the coffee break, so I will try to not take it too long. So this is a presentation about a small project in collaboration between ISRIC and DLR about creating high-resolution soil product for Europe, and hopefully to also to assess the user uptake for a future Copernicus service. So this is the general overview of the presentation. This is the working. I don't know. In any case, this is the normal digital soil mapping approach. So we have training data, we have covariate, we have a predictive model that can range from machine learning to AI to regression to anything, and then you get the soil map, but then you also get application, because just producing soil maps is interesting, but maybe not that useful. And the particular of this project is that for the covariate, we are using output produced from DLR, really doing processing of Sentinel-2 data with a quite complex workflow, as you can see, in order to create two products, that is the bare surface reflectance composite and the reflectance composite that I'm going to describe later. We are using input data from Lucas because we want to use something that is wider continental, but if relevant, we use also other sources in the ISRIC database called VOSIS. Covariate, we have the data prepared by DLR, but we also have a large set from Copernicus, so the digital elevation model, the land cover. We have geology and parent material produced by JRC. And we use simple radar product from Sentinel-1. We found that radar products are quite useful for some of the physical properties. The model is quantile random forest. Is a robust practical approach that allows pixel-based uncertainty assessment, and for us is quite important. The output are primary soil property. We will have an uncertainty index, and we are also working on other uncertainty measures like area of applicability and how well the uncertainty support the fine resolution. And we are modeling all of this for Europe at 20-meter resolution. So we have about 95,000 input observation for this property. These are the ones that we're trying to map. Soil organic carbon, soil inorganic carbon, pH in water, total nitrogen, sand, silt, and clay as compositional data, bulk density, oven dry, and coarse fragment on the volumetric. This is more or less the distribution of the data, and we can see that we have a nice gap in Norway, but kind of the other countries are covered up to 30 centimeters. That's why we stopped to the topsoil, because in another project, Holy Soil, we assessed what is available below 30 or 40 centimeters, and it was not that much. Yeah, the covariate, we use them to assess the soil forming factors, so climate, relief, organism, parent materia, and the radar as other, because it's connecting with quite a lot of the soil forming factor. So some words on the DLR product for Sentinel-2. It's called Soil Suite for Europe, has been released and made public available. I think that if you scan the QR code, you access the data. Is a 5-year composite between 2018 and 2022. The processing was done quite thoroughly and with a lot of information. This is the processing. They use this, and you have also the publication. They really use a lot of mechanism, filters, and assessment to make sure that they obtain the bare surface reflectance composite. For them, this is the main output. But as we need to do digital soil mapping for the whole of Europe, so not only for agricultural and cropland or for soil that can be bare, we also had to have products that were following a similar approach, but for permanently vegetated soil. And that became quite an interesting exercise, showing also a lot of difference in the processing. So this is an example of the product available. This is a map that shows where we have the bare surface occurrence, where we have permanent vegetation, and where we have other surfaces based on different correction. This is an example of the reflectance composite for the whole of Europe, not only for the bare soils. And it's difficult to zoom in a slides, but the details and the details in the land cover and how the soil and the land is used is quite interesting. And also this is a kind of a new product that is the standard deviation of the composite. So not only the mean, but also the standard deviation. And when you zoom in, really this is highlighting a lot of land cover changes and difference in land cover that are quite important for our DSM processing. So for the soil property mapping, this is more or less the list. The uncertainty was calculated as the interquartile range ratio over the median and multiplied by 10. And these are really preliminary cross-validation results. So the MAC is the model efficient coefficient, or the R-square on the one-to-one line. And yeah, some are decent, some are less decent, especially the organic carbon stocks is not that great. But this shows an initial attempt to make this product a 20-meter resolution using a 10-fold spatially averaged and cross-validation. These are the preliminary product. Really, they were out of my computer yesterday morning, so I am putting them as a really preliminary result. The brown is for carbon, and the greenish is for pH. And we also have some example for nitrogen. And if we zoom in area in the Netherlands, you can see a bit the details that this product shows. The number for pH are pretty high, but it needs to be divided by 10. It was still very preliminary results, but you can really see the difference in the field and in the different line filter and type of management that is happening in the Netherlands. Here we have carbon. I've been guaranteed that this filter here is real, is peat bogs that have been used for agricultural land, so you can still see the higher carbon. And we can see still some interesting patterns where we have a more blocky results, and this is due to the use of climate data that are at much higher resolution than the remote sensing data, but they still explain a lot and help a lot into continental-wide patterns. Similar for nitrogen, we can see the same, and also we have an uncertainty. This is just a ratio in which we have we go from lower values where in certain area to higher values. But for people that know the area, really the patterns make sense compared to the different fields, how they are used and how they are. And then there is a small section on product comparison, in the sense that just myself, I've been involved in the past 6 months in producing a lot of product for Europe. So this is just an example. I know it's not complete, because I know that a lot of other projects has product quite recently. So we have validation statistics point-wise normally, what I present in the cross-validation statistics, and we know how well the map represents this known point. But map users are often looking for areas in the soil landscape. So we would like to evaluate the DSM product by their spatial pattern and how well they reproduce the soil landscape as is known by experienced soil survey. So, and then try to help user to answer question like which is the most suitable for the user case, information accurate, landscape, one created for the scale of the application. This is a continental product. Maybe in Denmark you have 7,000 points just for a small area. So maybe using just the national product is sometimes more useful, or it's just we go for the most complex model that we can afford. And this is just a random comparison. These are 3 products taken from the table. I assign a random ID, so you don't know which one is which. The accuracy statistics were very similar, but if we look at the histograms, I'm not sure that we can say that they are exactly the same products. And this is important for the user for what they need to use, because in case this was SOC, this will be quite a bit difference in monitoring and in what the user can do with this data. And this is also the same 3 products as before, different histograms and different variograms, so quite different spatial structure. Yes, still use a continental variogram. I'm working on having slightly more local variograms, but still for me this is quite important to try to start to communicate to the users, because yeah, maybe one map is 0.1% more accurate, but then it has a completely different pattern in your region. Which one do you choose? On what you base your choices? And there should be another slide. Okay, and so as a summary, we use some innovative covariate produced from DLR. We have initial soil parameter at 20 meters. Hopefully, really, the link will be shared in the next couple of days. We did a lot of tests to check the best choice of covariate, and we need to bit solve the problem of the climate data being important, but at different resolution. And we need really a more thorough evaluation of the spatial pattern agreements between different products, and also how the uncertainty, which role the uncertainty is playing in the different products for the users. Okay, that was me. Thank you.